In this lesson, we're going to introduce logarithms. We're going to start out with graphs and kind of talking a little bit about graphs, but ultimately this lesson we're going to practice with logarithms more algebraically, and then tomorrow we'll go back to the graphs. But starting out, a parent exponential function. So the simplest possible exponential function is in the form y equals b to the x, where b is greater than 0 and b is not equal to 1. So unlike other types of functions where there is only one parent function, for example, if I'm talking about a quadratic, this is the parent function. There is no other parent function for a quadratic. With an exponential parent function, it's anything with a number to the x. So it could be 2 to the x, or 3 to the x, or 1/2 to the x. They're each their own starting point. They're each considered an exponential parent function. We have a rule. We have to use numbers greater than 0. I'm not going to really go over that now, but otherwise the graphs are wonky. And if I just made it 1 to the x, it would be a straight horizontal line. So that's not exponential. The base can be any number as long as it is greater than 0 and not equal to 1. So we're going to start out with the general, nothing plugged in, b to the x. And we're going to find the inverse. So we're going to switch x and y. That's still what we do for inverse. And then we know the next thing we have to do is solve for y. Now you can try a lot of stuff to solve for y. You could try to take a y root, but then you just put a y root on the x, which is not really helping anything. You could raise it to the 1 over y power, but then you're just moving that over. So basically with our current understanding of algebra, we don't have anything that undoes an exponent. We don't have an inverse function for an exponent. Now, really, what a logarithm is just the inverse of an exponent. It's something we can do to undo an exponent so we can get a y equals in, and when we're finding the inverse of an exponential function. The weird part, and what makes it tricky, is that whoever made this up decided they were going to use the word log for logarithm to signify that. So kind of weird, because all of a sudden we have a word in our math, which feels like it should be something else, but it's really just saying the opposite of exponents. So we'll clarify what opposite means in this case, but basically if we have something in this form, base to an exponent equals a number, so I'm actually going to rewrite this, base to an exponent equals a number. So this is the same thing, I just rewrote the b to the y first. Then we can take it and switch it around. Whatever's in the spot where the base is, which in this case is the b, for a logarithm, I write down low, like a subscript. Then I take the number, or what it's equal to, and I put it next to it, okay? Noticing that these two are on the same level and the base is lower, so x is not like an exponent. And then whatever was the exponent, in this case the y, becomes the answer. And now, by using this, kind of like remixing the equation, we have y solved, or the equation solved for y. So this is, the way we read it is log base b of x equals y. So we're just going to try that. Kind of feels like a weird rule without, any sort of use or anything, just kind of like, oh, we need to solve for y, so let's throw this word log in. But we're going to try that with two equations just to see kind of how it works. So for the next one, it says y equals 2 to the x. We're finding the inverse. So we switch x and y. Then we can write our logarithm. The base goes low, log base 2. The current answer, which we call the number, goes next to the logarithm. That's what we're taking the logarithm of. And then the exponent becomes the answer. So log base 2 of x equals y. So if I was to graph these two, this graph and this graph are inverses of each other, and they also ask kind of the opposite question, which we'll see on the next page. So here's another one, phi the inverse of log base 4 to the x. So now we're starting with a logarithmic equation. We're finding the inverse, so we're still switching x and y. Okay. Now here, we're going to peel it kind of back because, sorry, didn't put the y down. Just like the logarithm lets us write the exponential and solve for y, the exponential function, exponential form, will let us write the log equation, solve for y. So if I go back to exponential form, here's my base. We know our exponent, right, is the answer. So the exponent is x. And then this number that we're taking the logarithm of goes over here. So that's kind of moving it back. Now we have a little way to remember where stuff goes, and that's the words Ben and Benny. So we say when we're in exponential form, and it's really just kind of like translating. So exponential form is just a different way to write stuff. It's our usual way that we're used to. We have base to the exponent equals the number. So that's in the form Ben. So base to the exponent equals the number, okay? An equivalent logarithmic equation is in Benny. So when we have the word log, the base goes here, the number goes here, and Ben-E, the exponent, is the answer. So the exponent goes over here. We can nickname this log Benny or Benny. So if I have an equation, b to the y equals x, just like we had in that first one, we found the inverse. The equivalent logarithmic equation is like this. Now, when we start to do logarithms, it says when you see a problem in the form log base of number, this can be read as the exponent with the base of b that results in the number. So the word log we can also think of as meaning what exponent or the exponent, because we know the log is equal to the exponent. So when I see a logarithm, I'm saying what exponent, if it had this base, would give me this number.